Right, everyone. Welcome to our 5th class for AI. Today, our focus will be on machine learning and related technologies. Before we start, have you had any issues with the previous classes with data? No, good. Okay, let's see. Just need to hide this video panel. Okay, cool. Before we begin, I had a practical example of wait. Yeah. So this is not related to machine learning, but this is related to data analysis. How would you do data analysis? So what happened was that I'm part of this group, just a private group. We talk about investment over stocks, different kind of investments, and there was this one person who was really into deep growth investment stocks, and he presented this data for us. Not exactly for the class, but I mean like the people in that group. And he was very excited when he saw that this data shows the registration of new passenger cars in 2020 as 2021 as compared to 2020. And from his point of view, keep in mind this guy is an investor, right? He wants to buy shares of different electronic companies, different companies on the stock market, and he's looking for growth companies. That's his criteria. So he started looking at this data, and for him, he highlighted that Tesla has the highest amount of growth since he's looking for growth companies. Now his point of view was, and that's his point of view here. So his name is Akeem, and he says like, based on this data, Tesla is the second fastest growing car brand in Germany. It grew by 170%. That's a year-on-year growth all the way to the right. But if you look, if you look how much percentage increased from January 2020 to June 2021, that would be 431% increase. That's a huge amount of increase, right? Yeah, so he thinks that Tesla is kind of overcoming all other brands inside Germany. And yeah, the last sentence was we were arguing because I was telling him how bad build quality of Tesla is, and then he was like, but look at the data, how everyone wants Tesla. What do you think? So I brought this data to you, and I'm wondering, do you agree with his point of view when he says that Germans are switching over to Tesla, or Tesla is becoming like the most loved brand in Germany? Just by looking at this data, not by any other thing you might have heard. So to help you out, of course, the biggest point is the increase, right? You have 431% increase, that was year on year. And then you had 169% increase compared to the last year. And that's a huge and impressive growth for any kind of car company. Car companies do not usually have that kind of growth. If you look at other brands, you go all the way up to Volkswagen, BMW, Audi, Mercedes, year on year growth. I mean, the best they can do is around, after Tesla, that would be Mercedes, I guess, which has done a pretty good job. So I'm just curious, like, do you see any insights from this data? Do you agree with this person, or do you disagree?
It's the fastest growing, but it's not the biggest.
Yeah. Why do you say that?
You go from having 2 cars on the road to having 20,000 on the road.
Good point. Yeah. And you say that based on what? Yeah, okay. Right. Yeah, okay. Yeah, that makes sense. Yeah, right. Anyone else? No. All right. I mean, I kind of agree with you because that was my point as well. That's what I also kind of was curious about, because if you look at the top one, Volkswagen, for example, the growth, year-on-year growth is very less, 46%. As an investor, as people who are looking for growth companies, yes, Volkswagen is not really a growth company, but it's a mature company. It's something which has already, like from a data analysis point of view, 46% is less than 431%. But now you have to look at the context, right? If you ignore the context, which says like, you increase from 841 cars to 4,466. That's much, much lower than even the other brands. But I mean, look at the biggest one, Volkswagen, BMW, for example, Audi, Mercedes. So yeah, from a growth perspective, it's a growing company, but from the market share, it still has a lot more to go. So it's how you look at data. That's why everyone has a different perspective on the data. I just thought of discussing this with you because based on this point, this person went long on Tesla, and he was like, I would invest more on Tesla. And based on this factor, I was like, I'll sell all of my shares, and I sold all of my shares in Tesla. Yeah. Okay. Back to machine learning. So I'm in this slide, as I said, we will recommend you a few resources you could use. And a few resources are, this is a very cool book from Andrew Ng. Do you know who Andrew is? If you haven't, it's fine, but he's a very well-known name in AI. He used to work for, he set up the team for Google Mind. And then he went to Alibaba, set up their AI department. And then now he runs his own AI courses in Stanford. He has his own company. And the whole focus, what he's trying to do is to educate people in becoming well-known with AI. He wrote an excellent book. This book is, you can download it on Canvas. It's a free book. It gives you a practical idea on how to work with machine learning. So they kind of talk about what kind of data you can use, what kind of pitfalls would you face with data. Yeah, so these are like practical problems we machine learning programmers face on a day-to-day basis, and he has tried to like fix them. It's a very small book, so I mean they're like, I would say around, I don't know exactly how much, but it's not a thick book. It's a very, you could read it in an hour or two, I guess. The other one is a supervised machine learning slide, which I thought was very useful. This was taught in this university in a course called DIKU 004, but I've uploaded the slide for you so you can use it as a reference to this course as well. Right. So let's discuss some important concepts. The thing is, for us to discuss machine learning, even though I mentioned that you don't need to know mathematics, you don't need to know statistics, machine learning is all based on these things. So what I meant was you don't have to go like deep in and learn the basics of every single thing. You can just start working with machine learning. But I will just give you a brief overview of both statistics and probability. I'm sure you have kind of studied it before, but let's just go through that one. So as you already know, probability is something is how likely something will happen. And when we say how likely, the most easiest example is um, flipping of a coin. I mean, how many times will you flip a coin, and how many times you can think that it will get the desired effect. And of course, in order to calculate that, we have some mathematical formulas, which we have applied. And when you get the right probability answer, um, that field is called statistics. Another example of uh, oh yeah, another example is like dice, right? When you roll a dice, what will be the probability of getting a 1? And a very easy way to show it is would be P1 equals to 1 by 6. If you, oh, I have two things on, yeah. If you want to calculate what would the probability of rolling either 1 or 6, then again, the formula would be this. I mean, my job is not to teach you what probability is, just to cover the basics going forward. Now, why is it important? Why do we need to know what probability is? Because machine learning is all about probability. Machine learning is all about prediction. It's not about yes and no. It's about 100%, up to 100% probability that this can happen. In the driverless cars, for example, we make algorithms which predict if the incoming object is something the car can drive through. If it's a bird or it's actually a human, there's a probabilistic estimation over there. And based on that estimation, if the car thinks that it is at least a 10% chance that it's a human, the car should avoid it. For example, that's a probability. Bank fraud is all based on probability. All the machine learning algorithms, all the AI algorithms which run on fraud, they are estimated based on probability. If it's at least, I don't know, 50, 60% chance the person will commit fraud, it will be highlighted. So machine learning's base is all probability. And if you start digging more into how these algorithms are built, these are all statistical models in the base. What we have done as computer engineers is that we just have applied a high processing power to it. We have kind of transformed or given like a huge processing capability in the forms of algorithms, in the forms of GPUs, in the forms of ASIC computing. And that's what we call machine learning. But in the base of it, it's simple statistics, it's simple mathematics. There's nothing complicated about it. And that's why a lot of people who excel at machine learning are people who actually do not have a computer science background. They're the ones who have mathematics background, statistics background. Journalists, for example, that's a huge amount of people I've seen who have been working as journalists and they ended up working with machine learning. Statistics. Wait. Yeah, we kind of covered that, but let's see where we can use statistics, right? How statistics can actually help us out. So probability is one thing that you can define a probability as the outcome of something. How would you define the outcome? Statistic is collecting information about it and then putting into the data set and try to see how valuable that information is for you. For example, as we mentioned earlier regarding the Titanic data set, if you apply some statistic to that data set, you would see like very simple statistics. Those would be if you divide the data set based on gender and based on age, for example, and you plot it and you try to get some information on it. Another way to get more statistical information on the Titanic data set would be to see which passenger class people belong to and which ones of them survived or which one of them didn't survive. And then you could also put it into the people who survived and the people who did not survive based on their age. Okay, so let's see. So according to this graph, the people who survived, the highest amount survived who were 20 to 40 years old. And on the same time, the people who did not survive, the highest class was between 15 to 50 years old. So kind of shows that a lot of young people, no, but 15 to 20 actually died the most. There's another way to actually map it. If you also include the class on this data set, we'll get more information on the people who survive and who did not survive. Why? What was the reason that those are the ones who survived? Right. We also did, I mean, this is examples which I've taken from people, from the people who have actually done these statistical analysis. So, I mean, you can find a lot more examples around it. But when they they plotted based on age, gender, which port people boarded from, yeah. So like Titanic went from one continent to the other continent, and there were 3 places it picked up the passengers from. So the very easy information was that a lot of people boarded on Southampton, right? But of course, that also means that since most of them boarded from Southampton, 60% almost died who were from Southampton. That doesn't give us any useful information, but okay, this is interesting. Most of the 60% of people who lived, they boarded from Cherbourg, if I'm pronouncing this correctly. This is interesting that pretty much every male that boarded on Queenstown did not survive. Yeah, okay. For the few females which boarded on Queenstown, most of them survived. Yeah. So this data independently does not give a lot of information, but when you combine it, this gives a lot of information, and this can actually become the feature set for your algorithm. So what we do, another thing we do is using scatter plots. There's another data set which is called an iris data set. This is a collection of different flowers, their sizes, when they bloom, their petal length, width, and all of this information. It's a very interesting data set. So what people have done is they have kind of plotted it using scatter plots. Now, why am I showing you all of this information? That is because when you work with machine learning and you use the data, you use these kind of mechanisms to understand your data, and you try to get more information on this data. So you combine this you combine every column with every other column, and you try to get more insights into your data. And the more insights you get, the more you understand how your data is correlated with each other. And perhaps there is some feature set which you missed, and that's something which you should apply. And this, to make these plots and to make these graphs, it's very hard to do in Java or any other language, but it's very simple to do in Python. If you let's just write one line and it will make like a graph for you. Python is very strong in that essence. That's why machine learning is very easy to do in Python as compared to other languages, because it has a lot of data engineering pipelines around it. Okay. That was it on statistics and probability. The easiest definition for, there are a lot of the definitions of machine learning, but I think the easiest one would be that if you, without, if you want to create a system which kind of learns on its own without explicitly stating every single rule, that would be a machine learning application. But you have to make sure that the application learns from how things were done previously. Okay, so let's take a look at a few users. Yeah, so if you one of the uses of ML is like a cat search, for example. Like if you open up Google search box and you wanted to search for cat, what happens is that there are two ways to search for cat, right? One is a text-based search. So when you do a text-based search, the algorithm looks for annotations or metadata information, which is from the websites, right? Other way is image search. You can also upload an image of anything, upload it to Google search, and the Google engine will actually give you back the results. So the way this happens is that when you upload the image, there's a machine learning algorithm which kind of detects the pixels inside the image, and it kind of detects the same pattern with all the existing patterns it has already searched for. And when it finds the right one, it gives you the result. If it doesn't find the right one, an error is generated, and some human will look at that error and try to optimize the algorithm. The focus here is patterns. Machine learning works on patterns. So when you think about fraud detection, for example, the way we humans do it, for example, if you are working in the bank, right, and you're responsible for looking at the applications which come in, most fraud people, they get like a set of guidelines which others have learned over a period of time, and then they are told, like, look at this pattern, look if the person has said this in the application. And what happens is that after a few months that you have worked on the job, you understand what people are talking about. Most people talk about the same things. Statistics is very interesting in a way that it's very easy to determine what a lot of people will do, but it's very hard to determine what one person would do. And that's always the outlier. So in machine learning, it's the same thing. A lot of people are talking about the same thing. A lot of people in fraud will also do the same kind of fraud. Fraud cases, when you get like loan applications, fraud cases are very similar. It's kind of the same kind of frauds being committed over and over again. There are some geniuses who kind of come out with certain specific thing which never gets caught, but then most of the people kind of think about the same thing. I don't know what it is. It's genes. It's just what we hear in the media. It's the things we learn around us. But everything we do is mostly similar to what others do. But then there's one thing which becomes really problematic, and that's where AI kind of fails. Is that if AI is trying to detect the next terrorism attack, for example, it probably will fail, because those things are something which do not happen more often. They happen sometimes. Most of the historical information we get is based on our normal day-to-day behavior. And these things which happen, these are very, I would call it bias in the data, for example. And there are a lot of other factors also impacted. So AI is very good in detecting faces of people, but very hard at detecting when will be the next, when the next crime will be committed, when next terrorism act will be committed, for example. Yeah, based on historical information, yes. Yeah. Yeah. No, no, you're, yeah, yeah. That's a very good point. You're right. You're right. Hmm. Hmm. No, you're absolutely right. So yeah. Yes, yes, we can. That's called clustering. So what happens is that uh, what happens is, oh, I need to find that image. Um, I'll give you a real world example for that one. Router, for example, when we were working for customer complaints. So we made a system which, I mean, everyone in router who uses is obviously sometimes in their life have complaints. So you go online and you fill in a complaint, you send it in. So we started digging into our customer complaints, use some sentiment analysis on it. So first point was trying to understand how angry our customers were. If you do send a complaint to us, there's a huge probability you're already very angry. But you want to see how angry you were. There are nice people sending complaints, and there are very angry people sending complaints. But after applying sentiment analysis, we wanted to see what people were complaining about. So if you go to router.no, there's already a predefined level of complaint you can send in. You select the biggest category, you select the child category, and the further category down. And for example, it could be which area you're in. Then either you're having problem with the ticket sales, you're having problem with the bus, temperature, so on, blah blah. And then you kind of send a complaint in. Um, what we did was we used clustering, and we grouped all the complaints based on the keywords, not based on the keywords, the patterns of what people were talking about. So that's where AI kind of really helped us. Um, all all complaints which grouped together, which seemed people were talking about the same thing, they were kind of grouped together in one cluster, and they went together in one cluster. What we identified was that there were people who were there was a huge set of people who were talking about the bus driver having a bad taste in music. And people said, like, either there are two things people were talking about when we dug more. People said that either the sound was too high inside the bus, or the bus driver had a really bad taste in music and everyone else had to listen to that thing. The second thing we found was that people were talking about temperature. Temperature, we already know, people talk about it, but people were talking about bad air quality. Now, these are two different things, right? Temperature is different than bad air quality. You can have the right temperature, but you can have a bad air quality inside the bus. We had not captured that before. And the third thing was people complained that the buses were not wheelchair accessible. And that we already knew because it came in the media and it kind of got like a bad repo for it. But because of clustering, which we will read in non-supervised learning, we were able to cluster different textual of information and see what people were talking about, and able to identify trends which we could not see before. So we already have identified like list of 35 kind of complaints. We know people will talk about these complaints, but through this we identified 3 more. That's the power of AI, which you cannot really get based on your intuition. Okay. So I mean, if we were to give you that kind of a question and we were asked you like, hey, build like an ML, machine learning algorithm, and what we want you to build is using like image analysis. You upload the same thing like cat or dog, right? You want to do like a cat and dog thing. So what you would do is you would start by the steps which would be involved in that kind of algorithm would be collecting the data first. The algorithm you have to build is an algorithm which specifies if the image is a cat image, or a dog image. So first you collect all the data, then you label the data, you specify if this is a cat or a dog. Yeah. So when you are done with labeling, when you kind of, by label, I mean like you actually have to specify that this is a cat, that's a cat, that's a cat, and these are not cats, these are tigers, or yeah, another family. So you have to specifically write down. There are tools available for that. We will, one of the assignments, we'll actually go through that too. So once you are done with labeling, because labeling is actually a huge step for supervised learning. If you do unsupervised learning, you don't have to do labeling. If you do regression, you don't have to do labeling. But if you do supervised learning, which is most of the AI work, you have to do labeling. Most of the time we find labeled data, but sometimes we have to label it ourselves. So what you will do is once you have a labeled data, you will train the machine learning algorithm with this data. And since we discussed that the algorithm will look for patterns. Patterns can be anything, pixels. It could be a trend inside the data or anything. And yeah, once the model is trained, we'll try the model. We'll give it different inputs, and the model will kind of give us the output. So in the end, this is how a machine learning flow would be like. You have the input data, which would come out when the algorithm is actually completed. But you have a training data coming in, you train the machine learning algorithm, you create the model, deploy the model, you try with the test data, you see the prediction, you evaluate, and then you try the circle again and again. Yeah. Any questions, any confusions? We have discussed this earlier in the class. It's kind of similar to what we discussed earlier. All right. So let's talk about the types of machine learning algorithms. Now, these four, I want to go. I want to do in the same go. So I'm hoping if we can take a break now, instead of after 5 minutes. And how about we regroup at 3:25? Yeah. Okay. All right. Let's start. So as I said earlier, there are 4 kinds of machine learning algorithms. So whenever you will work with the machine learning algorithms, you will work within the 4 of them. The most common of them is actually supervised machine learning. But again, it depends on the use case you are kind of involved with. So what is supervised learning? So supervised learning is very simply that you know what kind of data you have. You supervise the algorithm by telling it, this is the kind of data I'm going to train you with. And then the model gets trained on the known data, and then you test it out with something new. And then the model will give you an output saying like, yeah, this is that or not. For example, in this case, we knew the images were for a particular fruit, banana, and we told the machine learning algorithm using data labeling as this data set is of bananas only. And when we tried out and we gave it an image of apple, for example, it will automatically reject saying like, this is not a banana, but here is actually unknown data, could be banana or an apple or anything else. So that is supervised learning. You tell, or you control the data and you tell the algorithm like, this data is this, and the algorithm will kind of train itself on that thing. Why would it be useful? Can anyone give me an answer on that? Why would supervised learning? Yeah, I'm sorry, could you repeat that? Yeah. Yeah, so when you have like a controlled data set, then you would use supervised learning. When you have control of the data around you, when you don't have control of data around you, that's when you use unsupervised learning. And by control, I mean like if you know exactly the kind of data you will get, if it's either going to be an apple, it's going to be a banana, it's going to be an orange, you know that this is the control data coming in. If it goes outside these boundaries, it's not a fruit data set. You also get for humans, you also get for animals. That becomes a data set you cannot control. Then you should not use supervised learning. You will use unsupervised learning. And that is unsupervised learning. So you have a data set, you know that from this data set, you want to predict it's either a banana or an orange, right? But data set is so huge that it's not possible for you to go through the whole data set. And it's probably more than apple and, banana and orange. It's probably pear in it, it's probably watermelon in it. So there can be many problems. Like one problem is the data set is composed of million images. You just don't have the time to label the data set. This could be one of the reasons. Then you don't use supervised machine learning, use unsupervised machine learning. Second reason will be that you think the data set has most of images, but there are also images of animals in it or humans in it. You don't have control over data set. Then you would decide to use unsupervised learning. So what unsupervised learning does is that it clusters the data based on patterns and pixels it finds in the data sets. When it comes to image, it's all about pixels. When it comes to textual, it's all about patterns. Binary is the same. But the process is the same, right? You give the data to the algorithm, it trains itself, train model comes out, then you try with the input data and it will kind of cluster saying like it's either a banana or an orange. Now, the question is, if you can do the things from unsupervised learning, why do supervised learning at all? Can anyone answer that? Like if unsupervised learning exists, and I also said that most people use supervised learning, then why not use unsupervised learning? Because you don't have to do data labeling in it. Did you raise your hand or no? Sorry. Yeah.
Probably more specific to individual cases. If you want to work with something specific, probably easy to apply to more specific problems.
Yeah, that's also a very good answer. Anyone else? Yeah. No, you're right. I mean, it depends from use case to use case, and also like the thing with clustering is that clustering is clustering itself has a lot of it's not 100%. So clustering will kind of try to predict an output based on how they identify the pixels or how the patterns are identified. But of course, the best you could get, for example, in our case in Router, when we cluster different outputs, different customer complaints, the best output we received was around 82%. So that means almost 18% of data was still wrong. So what most researchers or most programmers do is they use a combination of supervised learning with non-supervised learning. So they first use unsupervised learning, which kind of filters a lot of data. And when they get like the filtered data, because I mean, if you have a million set of images, you cannot label every one of them. So first you try unsupervised learning. Unsupervised learning will cluster the data for you, segregate it, filter it out. Then you will have like a very refined data set. Then you can put some do some data labeling on it, because now you have reduced your data set from 1 million to almost few hundred images. And then you use supervised learning on it. So that's also done quite a lot. The third one is called reinforcement learning. Now, reinforcement learning is pretty cool. This is where we try to make like a general AI, in which you try to make an AI agent which learns from its mistakes and by the positive things. So whenever the model produces a result, the result is improved by either giving either incentivizing the model by giving it a plus point, or decentivizing it by taking some points away from it. So reinforcement learning is used a lot within games. When you have like when you're playing games and you have some kind of AI agents, which are like one-person shooter game, right? And you're playing with other enemies. Some of them are already trained for every kind of instances, but some are AI-based agents, which learn the way you kind of are playing in the game. That comes from every time when you increase the level of the game. One of the instances, the way they're trying to develop is that every time in a one-person shooter, when you shoot the other person in the game, that's kind of a decentivized for the other agent, right? So that agent will learn that if I stand over there, if I'm standing with that particular pose, I will be shot. So that kind of that AI agent then learns that next time I should not stand there. On the other hand, if you're on the same team and you complete a level, you pass a level, and the AI agent is on your side, then the agent will learn that if I take this path, then I will be incentivized. I'll get a plus point. So that's reinforcement learning. You train the agent by giving them plus or minus scores. It's the same thing as like this. In the labs, they kind of train the mice when they have to find their paths to a maze, and sometimes they have to look for cheese, sometimes they have to look for something else, and when they find the right thing, they kind of they go around the maze. So reinforcement learning is kind of taken from the same context. And yeah, so even though I think reinforcement learning is pretty cool, it's being used a lot in driverless cars, because what they do is that they create a simulated environment, and then they let the car drive on its own. That's autonomous driving, right? And the car will be incentivized every time it goes a straight path, or decentivized every time it hits a pedestrian or some other object. But the biggest problem with this kind of reinforcement learning is kind of setting up the simulation environment, because if you are making games, you have to have a gaming environment. If you are going for driverless cars, you have to have a driverless car simulation environment. So it's expensive. It's expensive to work with reinforcement learning. And then the only way you can communicate with the agent is through the penalties and the reward system. So in supervised learning, non-supervised learning, you can tweak the model, you can change the data. But in this kind of reinforcement learning, you only can increase the amount of award you will give on a specific point, or the amount of penalty you will apply. Yeah, so the question I got was, is that how AlphaGo learned to play Go? So AlphaGo, I'm not sure how many algorithms were involved in that, but the base, yes, one can assume that the base would be reinforcement learning, but there was much more than reinforcement learning in AlphaGo. It's a very, very complicated game, and algorithms on that scale it's not one algorithm working on that one. It's a collection of different algorithms. Yeah. So let's see. For some reason, yeah, okay. So that's an example of a reinforcement and an AI agent using reinforcement learning. What it's doing is just like whenever it hits something, that's a, yeah, that should not hit, right? It should go around and keep on learning while it's going around. This is a very common game being used for implementing reinforcement learning. Then, okay. Okay. Atari, has anyone played Atari? Yeah, cool. I thought I was the only one because it's a really old one. So this is an Atari, yeah, it is Atari. So this is also an example of how you can make yourself a reinforcement agent. These now, why are the gaming environments so old? Like the graphics are so bad, right? And the previous one was also the similar one. That's because it's very easy to make a simulation environment for older games. The new games require a lot of processing power just for GPU. The graphics are so cool that just to set up the simulation environment, you need to have a lot of uh, physical power to make it happen. These games are very simple. They don't require so much processing. So if you want to work with reinforcement learning, a lot of the use cases would be these kind of games. So this is just an example of an agent which was developed using reinforcement learning. And like initially when they ran it, it kind of, it was slow, not that slow, but then it learned like, all right, how should I increase my points? And then it started going faster and faster and faster. And with this game, if you have played it earlier, the faster you get the points, the speed will also increase. Yeah. This is another example, right? The assault game, again in Atari. I've never worked with reinforcement learning, but if any one of you would like to work with it, I mean, it will be a cool project to work with. It's not hard to work with because as long as you have the simulated environment, you just, it's like a few lines of code you have to tweak, and then you get the right output. Then what they also did was they used Pac-Man. And with Pac-Man, they did the same thing, right? Of course, the reward is trying to eat that bigger point, and then the penalty is if you get eaten. Now, after a while, these games kind of get really boring because when you make an agent which kind of learns from its surroundings, it will always win. But what are they trying to achieve from these games? So what they do is like, when you make an agent which has learned from its surroundings, they can then use this agent and apply it on real world scenarios. So has anyone played that game, which was, before Fortnite came, there was very famous World Warcraft, I think. Has anyone played that? No, Minecraft is very famous, you're right. But there's another one, which is, it's like a wizard or something. It's kind of Fortnite thing. So you make up teams. I'm sorry, I can't remember the name right now. So what happened in that game was that it was kind of Fortnite thing, but it was based on old times. So you had you can choose different characters, and yeah, it became very famous. But the whole environment was set up in virtual. I mean, that the game since it was released around 2008 and it went all the way to 2016, the graphics weren't really that good as they are now. So what Google, the way Google the way Google kind of trains its driverless cars is that they have created an agent using reinforcement learning in that environment. And since that game has been played over 10 years approximately, that game has kind of logged all the entries from different users. So it has history of what people do, where people move around. They even have multiple universes which exist inside that game. So Google used it because it had all the environment of a functioning ecosystem as it be in our world, for example. And then they just created an agent, a car which goes around and which is incentivized to not hit people, not hit objects. So what they do is when that agent kind of trains itself and becomes like, kind of has a right score, they apply it to their original car, self-driving car. And that's one of the ways they train their autonomous driving vehicles. Yeah, and I mean, of course, when you have all kind of gaming companies making their own games, that's how they train their AI agents too. So if you would like to try out some reinforcement learning in games, try this link. It's called gym.openai.com. They have a few virtual environments already available. And you could check it out. OpenAI is actually a very good resource to learn AI. So we studied supervised learning, we studied unsupervised learning, we studied reinforcement learning. Now the fourth one is called recommendation systems or recommender systems. I mean, can anyone give me an example of recommendation systems? Yeah. Yeah. Correct. Yeah. So that's also kind of recommendation based on what you have purchased earlier. Do you know when did recommendation algorithms became famous or started being used? Even I don't know. I'm just gonna guess. Yeah. Sorry. When they started using it, it could have been Google, but do you know when it kind of started becoming really publicly used? Like a lot of companies started using it at the same time. I think this happened. I don't have the right answer, but I think this happened when Facebook came in, when Amazon started getting more attention, when Twitter started getting more attention, and then two friends having kind of similar profiles started getting different kind of ads based on where they lived, what kind of interests they had. That's when the power of recommendation system, but that's when people started exploring recommendation system. I do know that recommendation systems are not that old. They were introduced around 2010, I think. Yeah, the first recommendation system, that's the concept came out and then all companies started using them. So it's one thing to have the concept, other thing is when people start implementing it. And nowadays, a lot of companies, AI companies, that's the way they kind of uniquely identify themselves. TikTok, for example, when TikTok was being forced sale to US, you know about that, right? When TikTok was being forced sale to US, Trump kind of mandated that it would be forced sale to it. One of the biggest things China did not allow TikTok to sell was its recommendation algorithm. And that was a huge algorithm because this is not one algorithm, 10 people working with this kind of algorithm. It's thousands of people working on these kind of algorithms. For a company like TikTok, it's at least thousands of people. And one of the biggest things that China stopped the sale of the whole TikTok thing, saying that this algorithm should not leave the country. That's the unique selling point of that algorithm. It's not TikTok, which is like TikTok, yes, has a very nice UI. It's a good enough algorithm to use. But if you do not get the right video for you while you're on TikTok, then you might lose interest while being on TikTok. So when TikTok competes with Instagram, or they compete with Facebook Reels or other these kind of apps, it's not the app competing, it's these teams who are competing. And for them, every single feature is very important. They collect, I don't know, thousands of features for their algorithms. They don't even have one algorithm. They have a lot of algorithms working simultaneously. And that's what becomes kind of a company's IP, for example. Like TikTok algorithm was so powerful that Chinese government had to intervene, saying that this algorithm should not leave the country because AI is so important for us. And I mean, they're using in TikTok, but the same concept can be applied to different things. You can have recommendation on any single thing. So personalization and recommendation is something we do on a daily basis now. Like even in Router, we are trying to make a recommendation algorithm. So based on what you have traveled before, we want to recommend what time should you leave your class, your school, your house, and what kind of bus you should take. So it's kind of it will be used in almost every company going forward. Yeah, I mean, Google, Netflix, Facebook, Spotify, Amazon, these are the big giants, right? But I mean, almost every company uses recommendation system nowadays. And just to give you an idea of the branches of machine learning and what kind of use cases they do. So if we go all the way to supervised learning, we have supervised learning has two more types. We're going to study all of them, right? So one of them is regression, the other is classification. Classification is used in identity fraud, diagnostics, image classification, customer retention is also a very good use case for it. Regression can be used for forecasting, what kind of, especially when it comes to predicting the weather, you use supervised learning regression algorithm. Reinforcement learning, we learned that gaming, they use a lot of reinforcement learning. Robots, when they have to go around, they also use reinforcement learning. Unsupervised learning can be used, like there are two more, clustering and dimensionality reduction, but it can be used in customer segmentation. And this is also very cool. Customer segmentation part is also very interesting. Like every company right now wants to classify how their customers are. So if you are a customer of Facebook, right? Because Facebook would like to classify you as a person who has a specific age, lives in a specific area, because they have all this information. Like they have they have address on where people live, they have address on how old they are, they have address on their likes, they have address on things you buy on Facebook, they have information on how you communicate with your friends, how often you log in, how often you check other sites. So based on this information, they classify you. So what we are studying nowadays is customer segmentation. So there's one group of people. So every one of us is based or located in a group of people, right? People of my age, my interests, living in that specific area might be interested in buying this specific product. People of your age living in this specific area might not be interested in this, but they can be targeted with something else. So what they do is they combine customer segmentation with recommendation engine, and then they target people based on their interests. This is pretty cool because this is something when you use the power of data, combine it with AI, and you uniquely identify what your user wants to buy. And then you present them with that ad, and they actually go and buy that. Now, a lot of apps are trying to do that. For example, well, I'm not going to say their name, but a few of the clothing apps which I'm trying, right? They're very stupid in a way. Like, I bought a hoodie, and then all the recommendations I see of what it is. Now, I bought all the hoodies I needed. I'm not going to buy more, but I keep on getting more recommendations. But there's another app I tried, and now what that app is trying to do is that it's trying to give me more fashion ideas on what things I can try. But there's only limited information they can work on. So the more time I spend on the app, the more images I click on, that's also information they are saving. And when they get that data from me, then they will give you more information on perhaps this is something you would like. So from a personalization point of view, this is very powerful. This is how you make people more addicted to the apps, more addicted to the services. People can come back. That's what drives up the profit. So it's another discussion if it's wrong or right. But when it comes to how this is done, it's AI. It's all AI. And companies who have been able to invest on this technology and have been able to implement it the right way are the ones taking the lead. And that's why no one can, I mean, these are the five giants we hear about all the time: Google, Facebook, Amazon, going forward. And I mean, it's very hard to compete with them. Like, you have a lot of Norwegian startups competing with streaming services, like competing with Netflix. We talk about content, but content is one thing, but personalization is another thing. Based on what you have watched, you will get a lot of recommendations. It's not as easy as just saying, hey, you watched that movie, so we think you will watch the other one. It's a lot of factors involved on when you clicked it, while you were browsing through it, and when you made the decision to watch that movie, and how much time did you actually spend on watching that movie. Did you actually stop the movie while watching it? And based on all these factors, our recommendation engine makes a decision like, yes, you should watch this next movie. So to finish it off, when should we use machine learning? That's also a very important decision, right? I mean, it's not everything which AI can solve. Most of the things you might not need AI to solve that. But when it becomes obvious that a lot of the handwritten rules are becoming too complex and it's just getting out of control, that's when you should think about moving to machine learning. For example, in facial recognition and speech recognition. And if you also see that the rules are constantly changing, like you don't have a predefined set of instructions, but you have to look at the previous data and then you have to infer, then that's the job of a machine learning. Like most of the people who work with customer service, most of those things can be done using machine learning, because they are the ones who, yes, they do have a set of instructions on how to respond to customers, but sometimes it's based on intuition, and that intuition comes from based on previous experiences. So you have to make a decision based on what you have done earlier in those instances. And the third one is when the nature of the data keeps on changing. Like, yeah, most of the times you'll have control data, but if you get like uncontrolled data, for example, like stock trading or energy forecasts, then you should use like think about using machine learning. Which reminds me, has anyone noticed that electricity is super expensive nowadays? Do you know why? Oh yeah? Is it only because of that? But don't we produce our own electricity? Okay. Okay. But I mean, if we sell it, are we selling it? Are we selling the excess electricity, or are we just selling the normal one? How are we doing that? Oh yeah. So it's not sold on a national level, it's sold on a regional level. Yeah. Yeah, I see. Yeah, okay. I see. All right. You raise your hand in the back. I don't know if you have. Ah. I see. Yeah, I see. Yeah. Yeah, but thank you for the input. I was just curious. I was like, why is it going up? The bill, my bill is going up. I'm sure your bill is also going up. I was just curious. Yeah. Damn, that is bad. Yeah, yeah, I see. Um, one of when we talk about environment friendly thing, right? You mentioned like the green electricity being sold off. Um, we were talking about now a lot of companies are buying batteries, right, for electric cars, and even we are buying batteries for our electric buses. And then it's one point to say like, yeah, we're trying to transform the city into a more environment friendly, but then you look at where the batteries originate from, and then they are like child labor is involved in that one. So Ruther on a general level is also kind of discussing these points, like how far should you go? So you should call yourself an environment company, and there are like ethics involved in that as well. But on the bright hand side, a lot of Norwegian companies are setting up their businesses inside Norway, which are creating the batteries too. So I was told like Grimstad, they are setting up some factories in down in Grimstad and Arendal. That was cool. Good to hear that. Just to say, our lecture is over now. We don't have anything else to discuss. But regarding the lab, we do have an excellent lab for you. We will also assign an assignment, give an assignment. So there are 3 assignments. One of them will be published by tomorrow. I just have to finalize the data set. But yeah, it will be published by tomorrow. Go to the lab, see what Theo and Atika have actually designed for you. It's about data cleansing, working with data more. So the first assignment won't be on machine learning, that would be around data. The second assignment will be on machine learning, and third will be on something else. All right, thank you for today then. For Zoom, I'm going to sign out now.